Hello friends, welcome to third year mechanical engineering. I am Jaydeep Bhaskar. I am assistant professor in mechanical engineering department of Sanjeevani College of Engineering, Kopargaon, Maharashtra. I am your teacher for subject of design of machine element part 1. Today we will go through introduction, prerequisite and correlation of our subject with other subject. So what are the prerequisite of this subject? For this subject, you require knowledge of following subject. First one is basic mechanical engineering. So in first year basic mechanical engineering, you might have studied different machine elements like shafts, keys, coupling, gears, belts, joints, etc. This knowledge from basic mechanical engineering is needed. Second, in engineering mechanics in first year second semester, you might have gone through calculation of unknown forces, reaction, moments using basic principle of forces like summation of force is equal to 0 in x direction and y direction. Similarly, summation of moments is equal to 0. Using this, you might have calculated unknown reactions, forces, etc. And third subject is strength of material. In this, you have calculated different stresses like bending stress, tensile strains, compressive strain, and a number of other stresses, torsional stresses are there, then shear stresses are there. You might have gone through. And one more subject you need to know for this DME 1, that is nothing but different steels and their material properties. So this is fourth part, that is material science. A little bit part is required. You can go through also different types of steels and their materials, because whatever materials we are going to use in DME 1 for calculation purpose or for project purpose are nothing but different types of steels. Obviously, material properties you will get from a standard book called as design data book. In this you will get type of steel and their properties. So these are the prerequisites from the DME 1 subject. Now what is our subject flow? How our subject is evolved, or how we are coming to the third year subject, that we'll try to understand now. Okay. So what you have studied in BME 1? In BME you have studied different machine elements, and you can identify different parts. Like if you see a shaft, you can identify, yes, this element is shaft. If you see a gear, you can identify, yes, this element is gear, etc. So yes, simply visualization of the part you know. Second is engineering mechanics. So in engineering mechanics you calculated reactions, unknown forces, but you have not calculated their effects. Suppose if you are applying some force, then bending takes place, deflection takes place, then stresses are generated, or if the force is more than the capacity of material, then failure will also takes place. So these effects of forces you have not studied in engineering mechanics. These effects you are going to you studied in strength of material. So whatever stresses are there, their effects you have studied. So how much elongation takes place, then how much bending takes place. Okay, you have calculated that in strength of material second semester. Now what is next in DME 1, that we have to study. So if you understand the flow of the subject now, first one is BME, that is basic mechanical engineering. Second is engineering mechanics. In that you have calculated only forces or moments, and in SOM you have calculated the effect of those forces and moments on the particular machine element. Using this knowledge we have to actually design different machine elements. Okay, so that we'll see now. Now actually we are going to start with the introduction of DME 1. Okay, so what does it show? It simply gives this is the actual time for a design of parts under given condition. Okay, this is the actual time. Up till now we have done only the analysis, but right now the time has come, we have to design a particular machine element under a given condition. For example, suppose I am giving some example. First one is design shaft diameter which transmits 10 kilowatt power with the speed of 1000 rpm without failure in torsional stresses. Obviously we can design this shaft diameter. What should be the shaft diameter so that it can transmit 10 kilowatt power at the speed of 1000 rpm? Obviously material and material property should be provided. That means suppose your shaft is made of wood or shaft is made of some steel, so those properties of the material should be provided. Then you can easily identify, or you can easily find out the shaft diameter. Second is design quarter joint which can take static load of 5 kN. Obviously for this also material properties has to be provided. Third one is design oblique select belt which transmits 10 kilowatt power. So we can design this, and here I have done one thing, that is design oblique select. So after designing belt, our belt may not be present, our whatever size of the belt we have calculated, that may not be present in the standard size. That's why I have said here select from the manufacturer's catalog. Next, one more example is there, design of power screw, so that we can lift the load of 10 kilonewton load. That means if you have to raise some load through some distance, suppose 15 mm, 20 mm, and of which magnitude is 10 kilonewton, weight of that vehicle is suppose 10 kilonewton, then we have to design that power screw. One more example is there, design the spring of a shock absorber. So what should be the coil diameter, what should be the coil length, what should be the diameter of spring, what should be the turns in the spring, so that all the things can be designed with the help of DME I. So I have given some examples. So you might be knowing now, up till now we have studied only the effects of forces, that is bending, deflection, etc. But right now, using this all the knowledge of your BME, then SOM, and then material science, engineering mechanics, we have to go for the actual designs of the parts. Okay, now we'll go through the which topics which topics we can study, or we have to study in the subject DME I. Okay, so topics to be covered in DME I. So first topic is design of simple machine elements. So which are your simple machine elements that we have to design? Quarter joint, knuckle joint, and parts with eccentric loading. So what is the quarter joint, knuckle joint, what is the application, where it is used, that we'll see while seeing the actual first unit. But our first unit is not limited to the quarter joint and knuckle joint only. We can extend it to some other parts also. That parts may not be in the syllabus for understanding purpose, but for understanding purpose and for some own purpose, we can go for some other elements of the design also. But for syllabus, you are having quarter joint and knuckle joint only. Fine. Next is design of shaft, keys, and coupling. So this is very important unit, design of shaft, keys, and coupling, because we have to design shaft, keys, and coupling not only in this semester. In DME II also we have to design this shaft, keys, and coupling, and in last year also we have to again design this shaft, keys, and coupling. And this will be taught only once in the DME I, that is design of shaft and keys and then coupling. Okay, fine. Next, unit number 3 is design against fluctuating load. So this topic is little bit new to you, because we have not dealt up till now fluctuating load. So static load is nothing but magnitude of the force remains constant for with respect to time, and with respect to time, if the force magnitude does not remain constant, it varies, it continuously varies, then it is called as fluctuating load. So this topic is little bit new. In this we have to understand certain new concepts also. Unit number 4, power screw. The example of the power screw we have seen in the introduction, that is, suppose we have to lift the load of 10 kilonewton. Okay, and suppose some example I have given, that suppose your vehicle get punctured. Which vehicle? Four wheeler get punctured. At that time we are keeping a simple screw jack there, and we are rotating that lever of the screw jack, so that vehicle will get lift. So in that case, whatever screw jack is there, that screw is called as power screw. This is one application of power screw, that is screw jack. We have to design n number of applications of power screw, that we are going to design in the 4th unit. What is your 5th unit? 5th unit is design of threaded and welded joints. So we know that threaded joints are there, welded joints are there. How they can be designed? For a particular turning moment. So here turning moment is there for particular 100 Newton meter turning moment or 1000 Newton meter turning moment. What should be the diameter of screw, or what should be the type of weld that we have to design. So design of threaded joint is different part, and design of welded joint is a different part, but these two parts are mixed in your 5th unit. Next is mechanical spring. So a simple example of the mechanical spring, I have given the springs which are used in the shock absorbers are there, then springs used in the ice engine walls are there. So how these springs can be designed, so that part come under the mechanical springs. So these are the 6th unit, that we are going to study in your DME I. Basically there is no any software part related to this, but which software part we can add? in your design project, that is term work part, you can do the drawing with the help of, or drawing and design with the help of some software like AutoCAD, or if you want to go for 3D uh, 3D drawing, then you can go for the geometrical. If you want to go for geometrical modeling, you can go for softwares like uh, CATIA or Pro E. If you are having, you can go through it. Next, this unit or this particular subject is very we can say useful for programming. That means we can solve n number of problems of DME 1 with the help of programming also. That means you can do the programming in MATLAB, you can do the programming in Python, C, C++, Java, whatever language you are familiar with or you are interested in, you can do, because simple formulas are there, and the formulas we can easily keep in the program. So that's why this unit is you can see this particular subject while writing the programs in the in particular software. Okay, so this is all about the introduction of this topic. So today we'll stop here. In the next lecture we are going to start with the actual first unit, that is design of simple machine elements. Thank you.